I'd like to show you I intentionally started with this problem because of the fact that I ended last week's show with this, and I told you that I made a minor mistake, and I apologized. I apologized that I'd made a mistake. But let me show you what I did, so maybe you don't do this down the road. All right, so let's take a look. This is what I just recently completed right here. So it's u times v. U times v. V was 2/3 times x minus 1. All right, so here, again, we had u times v. But u was x. V was the 2/3 times x minus 1. But I didn't put that there. I put dv. I put dv there. So I should have put u times v. I should have put x times v, where this was v. Not that. Okay? Not that. So that, I apologize. I made a mistake. But the reason why you study is because everybody makes mistakes. But the more you study, the more familiar you get with the material, and the more comfortable you will be. Let's look at another problem. Let's take a look at what's on page 487, number 15. Notice how I'm always doing odd problems, so we can check the back of the book and make sure that you understand what you're doing. All right, so here we go. Page 487, number 15. Take the antiderivative of t natural log of t plus 1. You don't see what I'm doing. Sorry about that. T natural log t plus 1 dt. All right, so again, all the techniques that you learned in Calc 1 may not apply here. They may not apply. So you have to now consider those techniques and then consider your Calc 2 techniques that we're learning. This is called integration by parts. Let's take a look. So again, what we told you is you're trying to match this up. You got the antiderivative of u dv is equal to u times v, all right, u times v minus the antiderivative of v du, all right? So let's call this u. Let's try that. Let's call that being u, and let's call this being dv. All right, let's call that u. Let's call that dv. All right, so now what do we have? If we call u natural log of t plus 1, and we call dv t, all right, so now you'll need du, which is, you'd have to know how to take the derivative of a natural log. It's 1 over t plus 1, all right, 1 over t plus 1 times the derivative of t, which is just 1. And then you'd have to take, to get v, you'd have to take the antiderivative of t, which is t to the second times half. All right. So now you have the antiderivative, original problem. All right, original problem is the antiderivative of u dv. You have a u and you have a dv. The way you take the antiderivative of u dv is right here, is right there. So you have the antiderivative of u natural log t plus 1 times t. The way you take the antiderivative of u dv is u times v. Ru was natural log. Ru was natural log t plus 1 times v. V is half t squared, minus the antiderivative of v, which is half t squared du times du, and our du was, minus the antiderivative of v, which is 1/2 t squared du, which is 1 over t plus 1. All right, so now you'd have to simplify that down a little bit. You'd end up with the natural log of t plus 1 times a half t squared, minus, you'd have to condense this down a little bit. So you end up with minus the antiderivative of, you end up with t, you could say t squared, this is t squared over, let's try to pull out the half maybe. Let's pull out the half here. The antiderivative of t squared over t plus 1. All right? And now you have to be able to take the antiderivative of that. You got to be able to take the antiderivative of that. So now it appears as though, as I look at this, one way you could take the antiderivative of this is to use an algebra or a Calc 2 technique where you use long division or you use synthetic division. I think that might be the way I would try to take the antiderivative of that. It looks like the easiest way. So you use a technique where you use synthetic division. You divide -1, and the coefficients would be 1. The t term would be 0, and the constant would be 0. All right, let's try to divide that. You bring down the 1, you multiply, you get -1. You add, you get -1. You multiply again, you get 1. Then you add, you get 1. So now this simplifies. Let's rewrite this problem. We have the natural log of t plus 1, and then you have half t squared minus half times the antiderivative. Let's rewrite this. This is now t. This is t minus 1 plus the remainder 1 over that divisor of t plus 1. Okay? This is much easier to take the antiderivative of than that. All right? That's much easier to take the antiderivative of. So now let's finish the last step. We have the natural log of t plus 1, all right, times half t squared minus half. Now you have to take the antiderivative of that. The antiderivative of x, now you're just using Calc 1 techniques. The antiderivative of t is just half t squared. The antiderivative of 1 with respect to t is just t. And the antiderivative of 1 over t plus 1 is the natural log of t plus 1. All right? And this is plus c. All of this represents your final answer. You could simplify that down. You could distribute the half, and you can do some other things like factoring. And I don't really want to do that because it's more algebra 2. I just want to spend time doing calculus work. All right. So notice how I'm talking slower. Notice how it's it's tedious work, and that's why you would need to study. That's why you would need to spend the extra time, like my students did earlier today. And you don't quit. You never quit.